Problem sheet 3, question 1. Describe in words the following queuing systems. And we have 5 queuing systems that are written in Kendall's notation. So this question is asking us to interpret Kendall's notation. So if we recall that Kendall's notation has 5 components. It has the arrival distribution, then service distribution, then number of servers, then the capacity of the system, that's the queuing capacity, and then the service discipline. And each of these 5 components are described using a letter or a number. And we need to interpret what those letters and numbers mean. So let's consider A. We have an M5 queue. So we only have 3 of the 5 components. What does that mean? That means that the final 2 components, capacity and service discipline, are assumed to be infinite capacity and FIFO service discipline. So an MM5 is equivalent to an MM5 infinity FIFO queue. This would be Markovian arrivals, also known as Poisson arrivals or exponentially distributed inter-arrival times. Markovian services, also known as exponentially distributed service times. 5 parallel servers. Infinite queuing capacity. And FIFO, which stands for first in, first out service discipline. Now consider B. We have a DM150. So the D stands for deterministic. Deterministic arrivals means that the time between consecutive arrivals is the same every time. 1 arrival every 5 minutes, 1 arrival every day, and so on. You could imagine this to be a doctor's clinic where patients are scheduled to come in every half an hour. We have Markovian services, 1 server, so a single server, a capacity of 5, and that capacity is the system capacity. So if there's 1 server and a system capacity of 5, that means there's room for 4 people to queue. And a service discipline of 0, which stands for service in random order. So of the 4 people who are queuing, we decide who's going to enter service next randomly. C, we have a G infinity system. And of course, this only has 3 components. This is actually a G infinity FIFO system. A G stands for general. So we have a general arrival distribution. So this could be Poisson, but we're also allowing this queue to be deterministic, to have gamma arrivals, normally distributed arrivals, or something weird and wonderful. Similarly, the service distribution is general. There are infinite number of servers. What does that mean? That means nobody waits. Everyone enters service immediately. There's an infinite capacity. And if there's infinite capacity of the servers, then clearly there must be infinite system capacity. Okay, nobody waits. And by default, we have FIFO service discipline, which is first in, first out service discipline. D, we have an M3D infinite PSQ. So arrival distribution now is denoted by m to the power of 3. So the m denotes that this is Markovian arrivals, and the 3 denotes a batch size of 3. That means that the time between 2 consecutive arrivals is exponentially distributed, but an arrival consists of 3 customers arriving all at the same time. We have deterministic services. Infinite servers. And infinite system capacity. And the service discipline is PS, that stands for processor sharing. And what that means is that the more people that are in service at any time, the slower the service rate. So the service rate is proportional to the number of people in service. And finally, E, we have an MA2601 infinity FIFO system. So this corresponds to the first component, the arrival distribution is M, that's Markovian arrivals. The service distribution now is denoted E2. That is an Erlang distribution with parameter 2. And an Erlang distribution with parameter 2 is the sum of 2 independent exponential random variables. The third component says we have 1 server. The fourth component says we have infinite queuing capacity. And the last component says the service discipline is FIFO, which stands for first in, first out.